and welcome to my demo. My name is Mahdi Anaya. This is for challenge assignment 1, flash memory programming with a Watchdog timer. Um, so this program will continually erase, verify, and program the byte 0xA5 into all bytes of flash memory. I used bank 1, and I will explain why I use that here in a little bit. On correct execution of this flow of my program, a green LED will show for 1 second. If the Watchdog timer ever expires within my system, it will force a system reset. A button press of switch 1 will force the Watchdog timer to reset, and upon a reset, a red LED will show. So let me go ahead and tell you about what I did. First things first is I created a buffer of 4 kilobytes as shown here. Within that buffer, I continually wrote the value hex A5 into it. The reason I did this was since I was using the driver libraries, as an input, it took a buffer of whatever size you'd like, and if you wanted to go ahead and write that into a certain memory location, you could. For simplicity, I went ahead and did that. As always, we will hold our Watchdog timer. We don't want our Watchdog timer to reset our system. We stop it, and here starts my initialization of my system. First things first is I needed to initialize my input for switch 1 and my outputs, my LED, my green LED and my red LED. That's shown here. We used port 2.0 for the red LED. We used port 2.1 for the green LED. As you see here, I set them up as output ports, and over here we used for switch 1 P1.1, and this is just shown right on the board that for switch 1 it's port 1.1, and we will be using a pull-up resistor. So let's continue on, or keep moving forward. So for my system, I wanted to run it at 48 megahertz. I'm a firm believer of getting the job done with whatever requirements were given to me. I picked 48 megahertz just because that was what I came up with first. That's actually what the Lab 3 did in their example for memory. Next, I set my wait state to 2, as shown on 5.8 of the data sheet, or table 5.8 of the data sheet. It gives you a distinction of the wait state you should use to interact with the memory controller depending on the frequency of your main clock. And so since we were running at 48 megahertz, they say you should use a wait state, or a wait state value of 2. We will be waiting 2 states for every interaction with the memory controller. And of course, we went ahead and set our frequency to 48 megahertz. On reset of the system, we need to turn on the red LED for 1 second, and this is what this is doing here. Moving forward, we needed to go ahead and set up the Watchdog timer. To do that, you need to use the password. Tell it which clock you're going to be using. I used B clock because within the user guide, it had already given me specific values to use, as shown here, for the amount of time you'd like to. If you're using this, you would, as you see here, it tells you, okay, if you want to use 1 second, you can use this value here for the Watchdog timer, and it has a bunch of other values that we can use. So for simplicity, that's what I just went ahead and did. Moving forward, the while loop starts. This while loop is pretty much the main functionality of our system. Pretty much what we do is always check to see if the switch 1 has been pressed. Next, or not always, but we'll poll the switch to see if it's been pressed. Next, we're going to unprotect our sector, as shown here. Next, we will erase the sector, verify that our sector has been erased, program all our sectors, and on success, we will show a green LED. So let me take you through what I did in each of these little sections. For unprotecting the sector, we need to do that before we write to a sector or interact with a sector, whether we're writing to it or erasing. If we're ever writing to it, we need to unprotect it. The way I did it was I went ahead and for every sector that I would interact with, I wanted to go ahead and deal with that sector, whatever it is that I wanted to do, whether it be to unprotect it, erase it, verify that it was working, verify that it was erased, or programming it. I just dealt with it on a sector by sector basis. After dealing with every sector that I dealt with, I would reset the watchdog timer as shown in the code. Using these driver libraries, it made it really simple for me. And then so that's what I did. Sector array I. This is an array that I have here. It's just an array with the inputs required to deal with specific sectors of the array. Certain sectors of my bank 1 memory. And for this one, it's an array of sector addresses. Over here, I just went ahead and defined these sector addresses for bank 1 for simplicity. I wanted to keep my code really simple when trying to interact with these driver libraries. Moving forward, I erased the sectors, like as I said before, using my sector addresses, as I just spoke about. Next, I verified that my sector did erase correctly. If it ever didn't erase correctly, what I do is I subtract I by 1, meaning that I will just redo that same operation on that sector again. The sector that I failed on, I will redo that sector. And once again, like I said, I will always continually reset the watchdog timer for every sector that I deal with. Moving forward, I now program the memory with the buffer that I spoke to you about earlier. It's with value 0xA5 throughout 4 kilobytes. Using the driver libraries made my life really simple, really easy. And finally, I protected the sector. The reason I went ahead and protected the sector is to show you that I have full capability to operate on my flash main memory. I've unprotected a sector. I've erased the sector, verified that the sector was erased, and programmed the memory with whatever value that I wanted to write to it. Finally, on successful operation of all these things, I will go ahead and show a green LED for 1 second. This whole operation, this whole while loop here, from here on to here, took me about 15 seconds to do. Being that we needed to do this operation every 1 minute, I needed to stall for 45 seconds. And this is what I do within this function. I'm delaying for 45 seconds. The thing is, I needed to within these 45 seconds, I needed to continually clear the watchdog timer about every 1 second, a little bit less than 1 second. I clear the watchdog timer so the watchdog timer doesn't reset. And 2, I wanted to be able to check to see if anybody's ever clicking on switch 1. And so that's what this does here for me. I'm always checking to see if somebody has clicked the switch, and if they have clicked it, then what will end up happening is we'll stay in this loop and the watchdog timer will be forced to reset the system. Let me go ahead and run this for one quick run just to show you that everything is working as was expected. Alright, here we go. Okay, so now we've gotten to erasing the sector. I'd like to show you that I have successfully erased my sectors all the way throughout the whole 128 kilobytes. Now I want to show you that I've been able to write to all 128 kilobytes. We're waiting on this to run really quickly. As you will see, we are there. Okay, very good. As you see, we've written throughout the whole 128 kilobytes of our memory, and I'll even go out to 3FFFFF to show you that, hey, I can write all the way throughout the whole memory. Next, I would like to show you my switch functionality. Right over here, I could show you that PAN. Okay, since we're using port 1.1, I want you to realize the switch. We're always checking to see if it's 0. Here now I'm clicking the button and there we go, and realize that, okay, look at that bit right there. Hey, now it's 0. That somebody's clicking the button. And just to show you that, hey, we were in this 45-second loop right here, and I was able to create this switch functionality. Now I will show you a hardware demo of the board. Thank you. Challenge 1 hardware demo. Hardware portion of my demo, I'm going to go ahead and reset the system. On reset, we see that our red LED comes on because it's a reset of the system. Here shortly we'll see a green LED come on. Green LED signifying a successful operation of the while loop that I just showed you within my software demo. I will now show you a demo of the switch working. As I hold on to the switch, I will continually reset my system. I will cause the Watchdog timer to expire, and hence the red LED comes on. To let it run through again, here shortly we'll see the green LED come back on, signifying that we successfully went through that while loop again. And there it was. If I let this run for another minute, you will see that we have another successful write. I'm going to go ahead and keep videotaping. I'd like to thank you for watching my video. Thank you and goodbye.